So in this question of Neet 2016, the first phase, we have a uniform disk of radius r and mass m. In this disk, a circular hole is cut out of diameter r. We are asked to find the moment of inertia about the axis perpendicular to the disk and passing through the center. So we will consider two bodies. One body we will consider is the circular cutout, and the other body is without the circular cutout. So if I call this as I1 and this is I2, can we write the moment of inertia I is equal to I1 plus I2 when the two are combined? That is, it becomes one single disk. Because by definition of moment of inertia, moment of inertia is a topic which is considered to be difficult by a lot of students. It is the equivalent of mass. So in linear motion, whatever we consider as mass, here we take as moment of inertia. So the kinetic energy of rotation is half I omega square, and in linear motion it is half mv square. Force is F is ma, whereas for rotation it is tau is equal to I alpha. So what is moment of inertia? By definition, if you consider a point mass about an axis of mass m at a distance r, then we have I is equal to mr square. That is if we have one single mass. If we have say two, so this is mass m1 at a distance r1, and there is another mass m2 which is rotating at a distance of r2 from the axis. So we have by definition the moment of inertia is summation mi ri square. That is, it is m1 r1 squared plus m2 r2 squared. So in this case, we can say I will be the summation of the two, I1 plus I2. We have to find I1. I is easy, I2 is also easy. So we can write I1 is equal to I minus I2. Let us find out what is I. For a disk, I is half mr square about an axis which is passing through its center and perpendicular to the disk. For I2, what will be the mass? Let's calculate that. For a disk, of uniform thickness, can we write mass is equal to volume into density. Volume is the area into the thickness T into density. Area, since it's a circular disk, it is pi r squared into thickness into density. So we can write mass is proportional to r squared, because if I do m1 upon n2, m1 upon m2, I'll get pi r1 squared t rho upon pi r2 squared t rho. Because the thickness is the same, density is the same. So m1 upon m2 is r1 squared upon r2 squared. So for this cutout, the radius is r by 2. So my m2 upon the total mass m is r by 2 squared upon r squared, or I get m2 is equal to m upon 4. So I know the mass of the smaller cutout is m by 4. Let's find its moment of inertia. First, about its centroid. So about its centroid would be about this axis. So that would be I centroid is equal to mr squared, but m is m upon 4 r squared. The radius is r by 2 squared upon 2. So this would be m r squared upon 4 2s are 8 4s are 32. That is my along the centroid, m r squared by 32. Let me write it over here. I centroid is equal to m r squared upon 32 for the cutout. So using my parallel axis theorem, for the cutout, I have to find about the axis, about this axis, which is passing through the center of the disk. So I'll use my I2 is equal to I through the centroid plus m h squared. That's the formula for parallel axis theorem. H is the distance between the two axes, which is r by 2. So I have I2 is equal to m r squared by 32 plus m by 4. So this is m by 4 into r squared, which is r by 2 squared, which is mr squared by 32 plus mr squared by 16. So if I take mr squared by 16 common, I'll get 1 upon 2 plus 1, which is 3 upon 2, or 3 mr squared by 32 is my I2. So coming back to a formula, I1 is equal to I minus I2. So it is mr squared upon 2 minus 3 mr squared upon 32, which is mr squared upon 2 into 1 minus 3 upon 16, which is 16 minus 3, 13 upon 16, or I1 is equal to 13 upon 32 mr squared. So this is our answer.